Suppose you are asked this question in a front-end interview. Implement a debouncer in plain JavaScript. How will you answer it? What is a debouncer? Debouncer is an optimization technique. There are times when you need to issue expensive server requests. If too many of these requests are made, it will hinder performance. So we want to limit those requests. Debouncer is one of the ways to do that. But how does debouncer limit expensive server requests? It does so by saying the server request will not fire until the activity that triggers the server request is stopped for a specified time. Let me explain. Suppose this is a Facebook page and user is doing some scrolling. Since Facebook needs to update the content when you scroll, some expensive server request is made. This is a good use case for debouncing. Suppose every time we issue a server request to load content, we will print expensive operations. Let's see without debouncing how many of these kinds of requests are being made. So I'll start scrolling. 99 requests just by a simple scroll. Because these operations are very expensive, just by scrolling, it will clog up performance. Let's see what will happen when we debounce it. I am still scrolling. However, there is no more expensive operations being made. I stop. Another operation is being made. I scroll, no requests, stop, scroll, stop, scroll, stop. So the idea is server request is not made until I stop the activity. In this case, it's scrolling for a predefined limit of time. I believe I use 300 milliseconds. If I keep that activity, my expensive request will never fire. So this is how you limit expensive server requests. Some of the other use cases of debouncer is suggestive text. Suppose I want to search for something in LinkedIn. The suggestive text is not going to fire until I stop typing for like some millisecond. Another use case is autosave. Suppose there's a button that says save that allows a user to save its draft. If the user clicked the button too many times, this is going to issue a lot of save requests to the server, and it is very expensive. Debouncer can limit the number of saves being made. You may also hear the word throttle, which is another optimization technique that is very similar. This is a very good visualization that tells you the difference between debounce and throttle. Let's move the mouse to this area. If we move the mouse, it's going to issue requests which will be represented in these vertical lines. I'm still scrolling. Notice debouncing is never firing, right? What throttle does is that it limits the number of requests within a time period. So the end result is it does not fire as often as regular. However, if I keep scrolling, debounce will never fire, but throttle will always fire. It's only when I stop, debounce fire. So this is the difference. I scroll stop, debounce fire. Scroll stop, debounce fire. But throttle will still fire when I'm still scrolling. Now let us implement debounce from scratch. I'll have an empty HTML page. In this page, I'm going to remove JavaScript and only keep the content, which is a bunch of h1 tags. Let us copy paste code from David Wash. What this code is going to do I'm going to modify a bit. Instead of resize, I'm going to do scroll. Rename it as inefficient function. So this is the normal without debounce function. Suppose every time we scroll, we will console log expensive operation. We scroll a bunch of expensive operations. So this is if you do not do debounce. So how do we do debounce? Before we do debounce, we need to be familiar with two functions: set timeout and clear timeout. I'm going to use the example from here. So we have two buttons. The first button, show an alert box after 2 seconds. It has a function of delay alert. This function will activate once we click on it. So what does this function do? This function has a set timeout. Once the timeout of 2 seconds expired, we will have a window alert of the string that was really slow. Let's click on it. It's about 2 seconds. There is a that was really slow. Open the console. Now, what is this timeout ID? Timeout ID is what this function returns. Let's log it. Click on it. So timeout ID is 1. The type is a number. If I click again, so you can see that the timeout ID will keep incrementing and it's initialized to 1. I click again, again. And of course, I need to clear all these. This function set timeout will keep track of a timer ID that initializes to 1. Every time you invoke it, the ID will increment by 1. The timer is really just a number. What this button do, cancel alert, is linked to a function called clear alert, and it cleared the timeout ID. Note the timeout ID is a global variable, all right? So you are clearing out the same timeout ID that you assigned from set timeout. So let's see, what does it do? I click on it. Before 2 seconds, I click immediately. There's no alert. I do it again. Click on it immediately. So you have effectively cleared out the timeout ID. That's why the window alert will never fire. Just to make sure that we are clearing the same timeout ID. No need to cancel out the type. Click on it. Click. So the first console log is the timeout ID of our set timeout function. The timer is 1. The second log, we are clearing 1. Okay. You can even do this. Recompile. What will happen? I just use the word 1. Click. It's the same thing. You can even use the number 1 to represent timeout ID. Now, if I click again, what will happen? Click. Oh, it doesn't stop. The reason being, the second set timeout has the timer ID of 2. However, I am only clearing the timeout ID of 1. So of course, it did not stop the window alert from firing. The takeaway should be, if you want to stop window alert from firing, you need to clear the same timeout ID from the timeout ID that set timeout return. So you need a global variable of some sort. So let us now write our efficient function. My efficient function. Let us do my efficient function. In my efficient function, I'm going to wrap this expensive operation inside a set timeout. So console log this whole thing will become a function with a delay, so let's say 300 milliseconds. Add more space. Now I'm going to assign a timer ID. Let it be a global variable. Now, and we need to clear timeout. By the way, you should put the clear timeout before set timeout, because if you put it behind, you will always clear the timeout. Let's see what happens now. I keep scrolling, nothing happens. I stop. There's one operation. Oh, operation. Yeah, scroll, nothing happens. Scroll, nothing. Scroll, stop. Scroll, stop. Scroll, stop. And this is what debouncing is really. Functionality-wise, this code has the same function as all the other debouncing functions you see in the market, underscore or Lodash. However, if you submit this code in the interview, you will fail. We will talk about the problems of this code later, but now I really want you to understand the intuition of this code. What is the intuition behind debouncing? We are always keeping track of the same timer ID that set timeout returned. As long as we scroll within the delay of 300 milliseconds, we will clear that set timeout. Because we cleared it, our expensive operation will never fire. So an important concept is you need to refer to the same timer ID. Can you see what's the problem with this code? We have a global variable. So how do we remove this global variable? Now let me ask you this question. Can you do this? Put it here. And why can't you do that? So this is failing. Why is that? The reason being, every time you call my efficient function, we have declared a new timer ID with the value of undefined. So when you clear undefined, invalid ID does not do anything. No exception is thrown. So this line of code, it becomes useless. Now set timeout returns 1, timer ID is 1. But the next time you call it, the timer ID is still undefined. Even if you initialize to 1, doesn't matter, because my timer ID will keep incrementing to become 2, 3, 4, so on and so forth. The timer ID is always 1. It fails because you are reinitializing timer ID all the time. So how do we resolve this? That's right, using closure. Let's get rid of this inefficient function. Let's have a higher order function called debounce, taking nothing. Have a private variable called timer ID and return a function. You will return an anonymous function with the content, these two lines. Get rid of this. Debounce. Let's see if it works. Refresh, scroll, stop. So it works. Now we have successfully made use of closure to make this timer ID a private variable. The code right now is still not good enough because this expensive operation is our expensive server request. Ideally, our server request function should be decoupled from our debounce function. So instead of putting it here, we should pass it in as a function of some sort. So what we can do is to move it over here and do this. Now this 300, we can also pass it in, passing two variables, 300, and receive it. Let's call it delay. So now our server request expensive function is decoupled from our debounce function. Let's see if it works. Refresh, scroll, nothing happens, stop, scroll, stop. Okay, so it still works. Some of you may wonder, why is timer ID only initialized once? Because it may seem like your efficient function, which is debounce, is called all the time because of scroll. So if we call efficient function, which is debounce, shouldn't we initialize timer ID all the time? So every time we call it, we are reinitializing it to undefined? That is false. The reason being, my efficient function, which is debounce is returning a function, an anonymous function, all right? This window.addEventListener is only run once. Once it runs, my efficient function will eventually become this anonymous function. So debounce effectively only run once. So you let timer ID only run once. There's no such thing as resetting timer ID. This anonymous function will become the event listener or the event handler or the callback for the add event listener. And whenever we scroll, this anonymous function will fire. Debounce doesn't fire. It is this anonymous function that fires. Because of that, we are always referring to a single timer ID. When it fires, it clears the previous timer ID, you reassign a new timer ID, so on and so forth. Just in case some of you are still confused why the timer ID persists over multiple function calls, I'll leave a link to this article where it explains clearly why it may look like you're calling debounce multiple times or you're not. It's only being called once. The actual event listener is not debounce, it is the anonymous function, the debounce listener. I'll leave a link in the comment. However, if you write codes like this, you're still going to fail the interview. To illustrate why, let us copy paste code from Git for Geeks. We're going to add a button. Let's initialize the button, call it button. Add button to the event listener, Alt Shift down, comment this. Where the button is going to listen for click. So when we click on the button, our event listener, which is this anonymous function, will fire. Let's see if it works. This is a button I click very fast, pause, so it's working. To illustrate why this is bad code, it has something to do with context, or the value of this, of the debounce function. There's a difference between the context here versus the context inside here. Now, this is a new context. Inside setTimeout accepts the first parameter as a function. So what you can do, to be more explicit, is to extract it out and call function, just pass this in. To illustrate why, we can log the value of this inside this function. Then we log the value of this outside. So this is the context of this anonymous function. This is the context of setTimeout. So let's see if there's a difference. Click the button. Line 35. The value of this keyword is the button. It makes sense, right? Because this anonymous function is the event listener. Who triggered this event listener is the button, right? Because we click the button. So the value of this is the button. However, line 38, the value of this is a window. So why is that? Why is there a change in context? Now this has something to do with closure and this keyword. What closure normally says is that the child function has access to the outer function's parameter as well as variable. However, closure cannot access the outer function's this variable, same as the arguments keyword. That's why there's a change in context of this keyword. In order to preserve the context, you have to either bind or apply. So what you can do is to assign a context. You can also use that. I'm going to use context to save this into variable context, save arguments into args, and bind it or apply it. Let's try it again. Everything is button, the context is preserved, and expensive operation is only once. The reason our last console log is window line 40 is because you do not have another event handler to rebind the context. So by default, the value of this is window. To clean up the code, what you can do is to simply bind and put it here. And we get rid of all these. Let's see if it works. Oh, this has to be a function, so you have to do. Let's see if it works. Yep, expensive function, expensive operation is only called once. Let's just compare against Git for Geeks. Get rid of this console log. Debounce function, let timer return a function, context, arguments, clear timeout, set timeout, arrow function. Cool. In conclusion, everything you need to write for the interview is these lines. This is about 8 lines of code. However, just from these 8 lines of code, it has a lot of concepts, specifically closure, higher order functions, this keyword, and async. There are 2 concepts that may trip people up. The first concept is, explain to me why timer ID's value will persist across multiple function calls. You have to understand closure in order to know that. And you have to understand what is the actual event listener of the button. The actual event listener is not debounce. The actual event listener is the anonymous function returned by debounce. So debounce is only called once. That's why timer ID is only initialized once to be undefined. Because of closure, across any function call, the anonymous function has access to the same timer ID defined here. Another concept that may trip people up is the value of this inside closure or context. Whenever you are inside a child function, in this child function, this child function does not have access to its outer functions. This is the outer functions, this keyword as well as arguments. So in order to preserve the context, in order to make sure the context here and the context inside here is the same, you have to either bind it or apply.